Hello friends, today's question is a 400 volt 50 kVA delta connected synchronous motor is given, okay, and it is supplying 12 kilowatt of load with a power factor of 0.86 lakh, and the windage and friction losses are given to us as 2 kilowatt and the core losses are 1.5 kilowatt, okay, and the flux is now increased by 30%. Then what is the new excitation voltage? Okay, so if we draw the equivalent diagram here, so how it will look like. So this is the supply. So let's say this is the supply, okay, and I call it as V, okay. So this V is given to us, okay, which is 400 volts. Now uh, X for this is 3 ohms, so I can write it as J3, okay, and again this is the excitation EMF, okay, so I write it as E, okay. Now what he is asking is he's saying that the synchronous machine supplies 12 kilowatt of load, okay, and also when it is supplying that 12 kilowatt of load, the friction losses and windage losses are 2 kilowatt and core losses are 1.5 kilowatt, okay. So if you see what will be the input power, so input power will be that load which is 12 kilowatt plus the frictional and windage losses which is 2 kilowatt plus core losses which is 1.5 kilowatt. Now if you sum this up, this will come out to be 15.5 kilowatt. So this is our input power, okay. Now we have the input power with us, so what we can do is we can calculate this current because the input voltage also is given, which is 400 volts. So what we can do is we can use the formula for power. So 15.5 kilowatt will be 15.5 into 10 power 3 watts is equal to 3 into V. V is 400, okay, into I, which we have to calculate IA, into the power factor, which is 0.86, okay. So if you calculate IA from here, then you get your IA as IA is equal to 15.019 amps. Now this IA is known to you. Now what you can do is from here you can apply KVL across this circuit, okay. So if you apply KVL across this circuit, then what you get is V angle 0 degrees, okay, I'm considering it at 0 degrees, is equal to IA into J3 plus E, okay. E is the excitation voltage, okay. Now here the only unknown is E, okay, and V is 400, okay, it is at angle 0 degree. So IA is, because it is at lag 0.86 lag, so it is 15.019 angle minus cos inverse 0.86, okay. So this is the angle. Now from here if you calculate your E is going to be V angle 0 degrees minus IA into J3, okay. Now if you substitute all these values and you calculate, then you get your E as 378.98 at an angle of minus 5.866, okay. So this is your E. Now this E will be proportional to Fi, okay, because whatever is your flux uh, that will be responsible for generation of this E. Now your flux has gone by up by 1.3 times, okay. So E will be now proportional to 1.3 of Y, okay. So this magnitude should also increase by 1.3. So if I write E new, that will be 1.3 times of 378.98, and this comes out to be 492.67, okay. So this is the answer to this question, okay. Since the voltage is proportional to the flux, okay, the induced voltage, hence E nu will also increase by 30%, okay. Hence it will be 1.3 times the original E, okay, which was during this load was being supplied, okay. So this is how need to solve this problem, and thanks for watching.